this video we'll talk about phase changes. A phase change in nature is when a substance changes from one form to another. Now, the really familiar examples of phase changes are melting, where a substance changes from solid to liquid, and vaporization or boiling, where an object changes from liquid to gas. Now, we're all familiar with water undergoing these phase changes, but many, if not most, other materials can have those same phase changes. Most solid materials will melt when they get above a certain temperature. Most liquids will vaporize when they get above a certain temperature, and most materials will experience all three of those phases. Not all materials do, or sometimes the conditions have to be just right, like you have to add extra pressure in order to keep some materials liquid, like carbon dioxide is kind of a noteworthy example where under most conditions carbon dioxide goes straight from solid to gas. It sublimates. But if the pressure is high enough, you can have it in liquid form too. So when a substance undergoes a phase change, it requires energy to make that happen. You have to heat up water to make it melt. But during that phase change, as you add heat, the temperature doesn't change. All of that heat energy goes into changing the internal potential energy of the water. What's happening essentially is that the water molecules are getting, their separation is changing, and so the potential energy between water molecules changes, even as the kinetic energy does not. So a phase change happens at one particular temperature, and once that entire phase change is complete for that whole material, then the temperature will change as you add more heat energy. So phase changes just occur at a single temperature, even though you're adding heat to the material. And once that material is done melting or boiling or whatever, then its temperature can now change. Now there are other types of phase changes in nature beyond boiling and melting. You might have heard about materials entering a plasma state. That's when electrons get stripped off of atoms. The atoms get ionized. That happens to some materials above a certain temperature. There are phase changes having to do with the crystalline structure of a material. The microscopic arrangement of atoms will change in response to temperature. That's a phase change. Materials can become magnetic or non-magnetic above or below a certain temperature. Materials can become superconducting below a certain temperature. And there's many other types of phase changes that occur in nature. But we'll just deal with the most familiar ones here of melting and boiling. So the amount of heat that gets added during a phase change is called the latent heat. Or it's proportional to the latent heat. The amount of heat is proportional to the latent heat. Latent heat is this property of a material that tells you how much heat energy you need to add to accomplish that phase change. So the amount of heat energy you need to add to accomplish a phase change is the mass of the material times this value L, which depends on the material and depends on which phase change you're talking about. So your textbook has tables of latent heat for different materials, for melting and for boiling. And as an example, I want to analyze water as it undergoes some phase changes and undergoes some temperature changes. So in this example, let's consider 1 gram of water initially at minus 30 degrees C, so it's ice, it's solid. And we want to see how much heat energy needs to be transferred to turn that water into steam at 120 degrees C. There's our question. And we'll look at this graph. This is known as the heating curve for water. And it's a representation of all the thermal processes that are going on as we heat up this ice. So the vertical axis is temperature. The horizontal axis is the amount of heat energy we're adding. So we start here at minus 30 degrees, where the water is ice. And during the first part of this process, as you add heat energy, the temperature of the water increases. It gets hotter until it reaches 0 degrees, which is the temperature at which the melting phase change occurs. Now, once the water's reached 0, this phase change begins to happen, this melting process. And notice that as we're adding heat energy, the temperature does not change. At a phase change, temperature is constant. So during melting for water, the temperature is constant at 0 degrees C the whole time. Once we've added enough heat energy to melt all the water, melt all the ice, so it's now liquid water, as we continue adding energy, the temperature can now change. And it keeps changing up until 100 degrees C, where we reach another phase change, the vaporization or boiling phase change. So now as we continue adding heat energy, the temperature is constant. As we're boiling off more and more of that water is going from liquid to gas phase. Finally, once we've turned all of that liquid into gas, as we continue adding heat energy, we can increase the temperature of the gas up to 120 degrees C, and then we stop our process. So how much energy is required to do this whole process? Well, we have to take each step separately. In step A, we raise the temperature of the ice. From minus 30 to 0. And so the heat required is mc delta T. I'll let you guys try this calculation out. That C value can be found in your textbook. Make sure it's the specific heat for ice. And also remember that M needs to be in kilograms. So turn your 1 gram into kilograms. And that should give you 62.7 joules. Step B here is this phase change from solid to liquid. And the heat required there is M times L, the latent heat of fusion. A lot of times people put a little subscript F there for this melting process. Once again, you can look up that value. You should find that you get 333 joules. Step C, we're raising the temperature of liquid water to 100. And we use the specific heat equation again, mc delta T. Look at those values, you'll find that this answer is 4,186 joules. Step D, that's a phase change. That's the liquid to gas phase change. Heat added is m times the latent heat of vaporization. Look it up, you'll find 2260 joules. And lastly, we now have steam. We keep adding heat to that steam. It gets even hotter. So we raise the temperature of steam from 100 to 120. And the heat required there, I should label these A, B, C, D, and E. MC delta T. 40 point, oops, 40.2 joules. So the total heat, you add these all up, (3,110) joules to accomplish this whole heating process. Now this is true for any material that undergoes these kinds of phase changes, not just water. If it were a different material, you'd need to look at the different values of specific heats and latent heats. You'd also need to make sure to use the different temperatures at which those phase changes occur, because 0 degrees C and 100 degrees C are the important temperatures only for water. No other materials have their phase changes at those specific temperatures.